The overall goal of the following experiment is to characterize the effects of ion recombination in a liquid ionization detector used for the dosimetry of a stereotactic radiation therapy system. This is achieved by using the two-dose rate method, which consists of performing a series of water tank measurements with increasing source-to-surface distances to gradually reduce the dose per pulse, increasing the collection efficiency in the detector-sensitive volume. As a second step, the measurements at different doses per pulse are compared and used to obtain values of the general collection efficiency as a function of the dose per pulse. Next, correction factors are calculated based on these collection efficiencies and are applied to the liquid ionization chamber measurements to correct for the recombination effect. The results show that ion recombination has non-negligible effects on dosimetric measurements when spanning a large range of dose per pulse.
The size and tissue equivalence of the detector active volume are two important issues when measuring small field, which makes this detector interesting to characterize, as it presents a very small sensitive volume filled with a liquid medium.
An advantage of this technique is the accurate positioning of the treatment head that moves along the vertical axis, which allows us to study recombination without having to change the whole setup, as in conventional Linux.
To begin, place the water tank under the treatment head as low as possible. Fill the tank with water. Next, align the water tank with the linac so its vertical sides are parallel to the vertical sides of the head, and use the laser to ensure it is in the correct orientation. Then verify the vertical